Section 7.3, page 433 is called More Multiplication Properties of Exponents. And the bottom of the page here is kind of what we're going to focus in on. That's going to be a big part of the lesson. The book is calling it raising a power to a power. Might be better if we call it raising a monomial to a power. So monomial, that was supposed to be. So basically what the book's saying is if you have something with an exponent and there's an exponent next to it outside of the parentheses, then basically you can just multiply those exponents together. So for example, they're showing here 5 to the 4th squared is equal to 5 to the 8th power. Rather than them just telling us this is how it works, just think about what we've talked about before with some of this stuff. So if you have something that's being squared, means you're multiplying it by itself. So 5 to the 4th squared would mean 5 to the 4th times 5 to the 4th. And then we can go back to what we looked at in the previous lesson. So multiplying like bases, you can add the exponents. We have 4 factors of 5. We have 4 more factors of 5. Then we have 8 factors of 5. Anytime if you're doing problems like this, you are welcome to rewrite it this way and not necessarily worry about the multiplication. The problem I've seen some people have is that they do the way the book's talking about, multiplying exponents, and then these other problems we were doing in the last lesson, we were adding exponents, and then they get confused, like when do I multiply the exponents, when do I add the exponents? So like I said, if this number on the outside is big, rewriting it like this, it's going to be quite a bit of stuff to write out maybe, but it will always work, and then it will just give you one thing to remember instead of 2 different rules. So just a consideration for you. Again, ultimately it's up to you which way you want to do these problems, but just mentioning what I've seen happen in the past. So problem 1, what is the simplified form of n to the 4th to the 7th power? So that's exactly what we were just talking about. So if you wanted to, you could actually just multiply those together. 4 times 7 is 28. Again, your other option, if you don't want to remember 2 rules, is you could rewrite this times itself 7 times. If you want to use dots instead of parentheses here, you can. That'd be a little bit quicker. And then you could look at all together 4, 8, 12, 16, 20, 24, 28. So n to the 28th power. Part B we're going to skip. We're not going to mess with that at the moment, although if you were doing the book's way, you could just multiply those fractions together. It would be x to the 2/6, which you could reduce to x to the 1/3. So if you look at the Got It 1, Part A, again, we could rewrite this and then multiplying like bases, add your exponents, 5, 10, 15, 20. Or you could multiply those together. Same thing for Part B. B, if you did it the book's way, just multiply those, would be p to the 20th. If we were doing C, for C, you do need to more do it the book's way to multiply those together. That would be p to the 1/8 power. And then D would just be also p to the 1/8 power. Problem 2 talks about using order of operations when you simplify an exponential expression. So you want to make sure you deal with the exponents before you multiply. So basically on this problem is that here this is being raised to an exponent, so we can't try to say, oh, I'm going to multiply these and add these exponents together. We don't do the multiplication before we deal with the exponents. So if you wanted to, what the book's doing is they are rewriting the problem. And then this -2 we could put as -2/1. If you multiply, that would be -10/2. -10 divided by 2 is -5. And then at that point, I would have maybe done a separate step here. At that point, we're multiplying like bases means you could add the exponents, so 3 plus -5, and you can skip over this step if you want to, would be y to the -2nd power. To the -2nd power, we don't want a negative exponent in our answer, so that would be 1 over y squared. If you were looking for a different route to do this, your other option would be that you could put y to the 3rd over 1. That second part is to the -2nd power, so we can make it positive by putting it in the denominator. And then at that point, we're squaring that, so y to the 5/2 times y to the 5/2 if you wanted. You could just multiply them using the book's way, but I'm just mentioning if you don't want to memorize 2 rules, this would be your other way around it. 5/2, since we're multiplying like bases, we would add the exponents, so 5/2 plus 5/2 would be 10/2, and then 10 divided by 2 would be 5. So then this would be y cubed over y to the 5th. And then you could just think about where you have more y's. We have more y's in the denominator. How many more is 2? And if you want to put a 1 next to that, and there's your 1 over y squared. So again, that's a little bit more involved doing it that way. So a lot of the rest of them, we may just kind of stick with the book's way of how they're doing it. But just again, make sure you have clear in your mind when you're multiplying. Kind of the idea is when you're multiplying, think about the numbers are right next to each other. Then you're multiplying. If there's an exponent, or if there's a base in between them, then you'll be adding them together. So kind of like, I guess, if you think about when you multiplying numbers, they're right next to each other. If you're adding, there's something in between, in that case an addition sign rather than a base, but it's kind of a similar analogy maybe. So if you look at the Got It 2 Part A, if you wanted to for this, we could go ahead and multiply those together. 6 times -4 would be -24. And then now we have that part in between. Multiplying like bases, we would add the exponents. So 2 plus -24 would be -22. We don't want a negative exponent in our answer, so that would be 1 over x to the 22nd power. Part B, similar idea. So we're going to multiply these. So that's like 3 is the same as 3 over 1. So 5 times 3 is 15. 3 times 1 is 3. 15 thirds. 15 divided by 3 is 5. And then at this point we can finish this off. We're multiplying like bases, so you can add the exponents. So -2 plus 5 would be 3. So w cubed would be our final answer. And then part C, again, we're not going to get into too much of this probably with the fractions, but if you wanted to do this one by the book's way, negative times negative is positive. That'd be s to the 5/2 times s to the 3/2, and then multiplying, we can add the exponents. So 5/2 plus 3/2 would be 8/2, and 8/2 is equal to 4. So s to the 4th power. Bottom of the page just mentions we can use repeated multiplication to simplify an expression like this. So this is them for a moment kind of doing what I mentioned earlier. So if something's cubed, you can take it times itself 3 times. And then what we could do, get all the 4's together, multiply those, would be 64. Multiplying like bases, add the exponents. A half plus a half plus a half is 3 halves. And then what the book's pointing out at the bottom is that basically this exponent on the outside, if you take that exponent to each part of that term, then that's another way then you can go from there and just multiply those exponents together like we talked about earlier. So if you look at problem 4, they want us to simplify this. So basically it kind of just is more about the second part. This whole thing is to the 3rd power. So if you're doing it the book's way, each part of this has to get cubed. So the 4 cubed, m cubed, n to the negative 2/3 cubed. And then they just worked it out from there. Negative 2 times 3 would be negative 6 over 3. Negative 6 divided by 3 is negative 2. And then they kind of just rearranged things a little bit here. They got their n terms next to each other. Then you can add those exponents, which would give you n cubed. 4 cubed is equal to 64. So that would be your final answer for that one. So if you look at the got it 4, part A, this first part we can just multiply those exponents right next to each other, the x to the negative 4th. The second part, this 4 needs to go into all of these. So 3 to the 4th, x to the 4th, and we've got to take y to the 5th to the 4th power. So 3 to the 4th power is going to be 81. These can be multiplied, would be y to the 20th. And then if you look at these x's, all these are being multiplied, so we can multiply, we can add our exponents. Negative 4 plus 4 is 0. So that's x to the 0 power, which is equal to 1. So basically those cancel each other out. And we're left with 81 y to the 20th. If you don't like the explanation about those canceling or have a hard time remembering that, this x to the negative 4th could have gone in the denominator. And then at that point, you could say that those cancel. There was a negative exponent, put it in the denominator, makes it positive. Part B, same idea. So each of these pieces takes the exponent on the outside. This part, we can just go ahead and multiply those if you want. That'd be c to the 6th. This would be c to the 20 halves. 20 divided by 2 is 10. 3 to the 4th again is 81. And then multiplying bases, now we would be adding those exponents together, would be c to the 16th power. So 81 c to the 16th for that one. And then part C, same idea. Everything here gets cubed. Everything here gets squared. Multiply these would be a to the negative 6th. And then the numbers we can multiply together is 5,400. With the a's, if you add those exponents, since we're multiplying like bases, add the exponents. 3 plus negative 6 would be negative 3. And then we don't want a negative exponent in our answer, so we will move that down to the denominator. So problem 5, just a real life example. They give us a formula for the kinetic energy of an object. and they're asking what the kinetic energy of this jet would be. So we're just basically substituting in the information they're giving us. Notice the velocity is being squared here, so we have to square each of those parts. And then basically we just have a lot of numbers we have to multiply out and work that out. This part we do have some tens. Those are like bases, so you can add those exponents. Gives us the 10 to the 9th. And then all the rest of the number stuff gives us this. And then the book went ahead and just rounded it off. It didn't really say anything about rounding, so I'd probably just leave it like it was unless they tell you to round, but that's what they did there. So this gives you an idea of how to work with more multiplication properties of exponents.